how do nerve cells work? If you've thought about nerves in any way, you've probably thought that they're working by electricity and that the impulse is traveling down that axon, just like wires going around your house. I don't fully understand the electricity that goes around my house, but I do know if I plug something into the socket in the wall, then I can use that electricity, provided I have a cable that goes to what I want it to do. It needs to have a cable to connect it. Like currently I'm recharging this laptop. I have a cable carrying that electricity to the laptop from the wall. So with that, then what is the electricity? Well, in the body, I understand electricity to be movement of ions, charged particles. That is actually electricity and how the information is carried. And just like in the house, I actually my axon has to touch the effector, or almost touch. We looked before with muscles and we realized there's a tiny space at the synapse. So neurotransmitters are required to jump across that tiny gap. But just like in my house, a cable is required. I had that axon must almost touch the effector. And then the effector has to have a receptor for the neurotransmitter. Just like I might have the wrong cable for my laptop. We've got plenty of electrical devices in the house, and sometimes I grab the wrong charger for my laptop. I pick my son's Chromebook charger or something, and it's like, this won't work with this. It's exactly the same here. I need on my effector a receptor for the neurotransmitter that particular axon will release. So let's look at all of those things in a little bit more detail. How are we going to get this electricity? How are we going to get ions moving to create this action potential, this electrical potential? Well, it starts off because we actually have a membrane potential around the cells in our body, and that's every cell in our body. That's not just nerve cells. And it's the membrane potential that we have around our cells is made up of the fact that all of our proteins that we keep inside of our cells are slightly negative. But those proteins are very big and they cannot move out of the cells. So we've got negative things, or things that want to hold on to negative charge inside our cells. We then have a permeability in our cell membranes to sodium through leakage channels. These are just like little holes. It's like having air holes in your house where air can just leak in and out. And sodium can just leak in and out of cells. But so can potassium, and potassium can leak out at a rate of 25 times more than sodium. Okay, so we then need to think about where's the concentration gradient. As I said, if things are going to diffuse in and out, it's going to go down its concentration gradient. So if you're in a house in the summer and your house is colder than the outside temperature, the hot air is going to come into your house and warm up your cold house. In the winter, the cold air is outside and there's much more of it than the hot air inside. The cold air is going to come in to your house. So it's all on concentration gradients. And that is the same here. So here I have a cell, and this is the axon actually, so it's going to go on for a long further time each way. We have more potassium on the inside of cells than we do on the outside. And we have more sodium on the outside of cells than we have on the inside. So if I open up a sodium channel, sodium wants to flow in. And sodium would take a positive charge with it, making the inside more positive. But I have 25 times more channels for the potassium. So the potassium, there's more of it on the inside, is going to flow out. And because the potassium is positively charged and it leaves the cell slightly negative. And even though the sodium is coming in to make it positive, it can't win. More positive leaves the cell than positive enters the cell. Hence, the cell becomes negative. Now, this is going to stop when the electrical gradient is such that the positive potassium does not want to leave the cell anymore because the cell's negative and it wants to stay positive with negative. So, for the most part, potassium's going to leave the cell, but it's going to stop at the point where the positive charge doesn't want to leave the negative charge. So there's an end point to this, and it's before the equilibrium is matched, so this never gets to equal on both sides because you have this negative charge drawing the positive charges towards it. At the end of this whole process, more positive has left the cell than has entered the cell. And we end up with a negative charge on the inside of the cell. And people in laboratories have actually measured that, and it gets down to about minus 70 millivolts. It's an actual electrical voltage potential, like in a car battery. If you measured the voltage on a car battery, you get an actual number. We can do that in cells as well. I'm not going to ask you to remember the numbers, but just know that really happens. This is something people have measured.